Hi everybody, Mr. Wyatt here, and today we are going to start topic 8, and we're going to be learning all about probability and discussing probability in mathematics. And so anyway, today we're looking at topic 8, section 1, sample spaces. And we have two learning goals today. One, I can construct a sample space for an event by using a tree diagram. Well, I wonder what a tree diagram is. We'll discuss that in today's lesson. And secondly, I can use the counting principle to find the number of possible outcomes in an event. And you're going to see the counting principle is actually very simple. It really just involves multiplying, which is weird because we don't think of multiplying when we think of counting. Um, but that's what we will be doing is multiplying. All right. So sample spaces. If you think of a football game, a coin toss is used not just in football, but in lots of sporting events to decide which team starts with the ball. So you see here, this ref, he's tossed the coin up in the air. One of these teams' captains has called it in the air. They've either called heads or they've called tails, and they're hoping that they will win the toss. So a coin toss is used in sporting events to decide which team starts with the ball. If you toss a coin once, there are two possible outcomes, either heads or else tails. Those are your two possible outcomes, heads or tails. Oops, I don't want to move that box. I wanted to write on it, but maybe it won't let me. There we go. Heads or tails, you have two possible outcomes. An outcome is the result of an action. Outcome, what happened when you did that action of flipping the coin? Well, it's either going to land heads or tails, one of those two. It isn't going to just land on its edge and balance there. That'd be pretty crazy, wouldn't it? So an outcome is the result of an action. An event is an outcome or group of outcomes. And the set of all possible outcomes is known as the sample space. So there you go. There's your term, your sample space. That's just where you're listing out all possible outcomes for an event. What do they mean by an event? We can talk about it being let's say that you're playing in a basketball game, and over the course of the basketball game, you ended up making 12 free throw attempts. You were fouled a few times. You had 12 free throw attempts. The event there would be, well, how many of them did you make? How many did you make? Okay, so that you'd have a group of outcomes. Each attempt would be a separate outcome. You either ended up scoring or you ended up missing the basket. Okay. All right, so let's look at an example here. Look at this menu. We have a lunch menu, and you have two main dishes. You can have grilled chicken or you can have baked chicken. If you don't like chicken, well, you're not going to have a main dish then, are you? And then we have three side dishes. We have a salad, or you could order just a vegetable. Maybe they have green beans or peas, something like that. Or you could order rice. Boy, that's irritating because what if I want rice along with a salad or rice along with a vegetable? Well, instead, we're going to select the sample space, which is the collection of all possible outcomes, for selecting a main dish and a side dish. So we only get to choose one of the main dishes and one of the side dishes. Onto your tray they go, and to your table you go to eat. Okay? So how many possible outcomes are there? Well, let's list all of the possible outcomes using a tree diagram. So here's how the tree diagram works. We have our main dish here, and we have two options, either grilled chicken or baked chicken. I think I'll call the grilled chicken G. And I'll call the baked chicken B. G for grilled, B for baked. Now, whichever one of those that you choose, you have three options for your side dish. And so, for example, if you get the grilled chicken, you could also get a salad with that, or you could get a vegetable with that, or you could get rice with that. Now, if you ordered the baked chicken, you still have those three same options for your side dish. You could get a salad with it, a vegetable with it, or you could get rice with it. Okay? So this is what's known as a tree diagram right here. This is a tree diagram, and it does show all of the possible outcomes. We have 6 possible outcomes. See, we have 1, 2, 3 here. We have 1, 2, 3 here. That's 6 possible outcomes total. If I want to list all of the possible outcomes, I could list it like this: grilled chicken with a salad, grilled chicken with a vegetable, grilled chicken with rice. And then we have baked chicken with a salad, baked chicken with a vegetable, and we have baked chicken with rice. Okay, and so this is all 6 of the possible outcomes for this situation. Okay, so you could call this your sample space. These are all the possible outcomes for this example. All right, so here's your sample space, all 6 possible outcomes. I'll label this sample space. Better move my picture up a little bit. That's your sample space. And this over here is your tree diagram. Okay, I'll label it below it. Okay, now I could have made this tree diagram by listing salad, vegetable, rice on top and have 3 separate headings and then put grilled and baked under each of those. You'd still come out with the same 6 possible outcomes in your sample space. But I would go with the main dish first and the side dish second, since that's how they appear on the menu. Plus, it's nice to only have 2 of these separate trees. If you went side dish first, you'd have 3 separate trees that you'd be making in your diagram. Okay? All right, so you roll a standard number cube. You know, we call that a die. That's singular, a die. If you had more than one, then you'd call them dice, right? But in math, we always call them number cubes because, you know, we don't want to imply that we're going to do any gambling. And if you're working with dice, you might be gambling and then you could lose all your money and you'll be sad. So we call them number cubes in math. But just know we're talking about dice when we see that term. All right, so you roll a standard number cube and then you toss a coin. I have a quarter over here. List the possible outcomes. How many are there? Well, if you list all your possible outcomes here, we could make a tree diagram to do this. Now, you have options. You could, since the die is shown first, maybe I'll just put 1, 2, 3, 4, 5, and 6 down, because those are the possible outcomes when you roll that die. It's either going to be a 1, a 2, a 3, a 4, a 5, or a 6. Now, after you roll that die, you're going to toss the coin. Your possible outcomes when you toss the coin will be either heads or tails. So off of each of these, I'll have heads down and I'll have tails down. Same thing here. I could roll a 2 and then land on heads or land on tails. Same thing for 3, heads or tails. 4, heads or tails. Boy, these tree diagrams get kind of big, don't they? 5, heads or tails. And the same thing with 6, heads or tails. If you count all of these letters across the bottom row, that's going to give you the total number of possible outcomes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 possible outcomes here. All right, and I could list all 12 of those possible outcomes. You know, we could roll a 1 and then land on heads, 1H. We could roll 1 and land on tails, 2 heads, 2 tails, 3 heads, 3 tails, 4 heads, 4 tails. Isn't this fun? 5 heads, 5 tails, 6 heads, 6 tails. Those are all the possible outcomes. You can see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possible outcomes if we roll that number cube and then toss that coin. Now, if you had wanted to just put heads in on the top and tails over here, and then put 1, 2, 3, 4, 5, 6 under each of those, you're still going to get your 12 possible outcomes. Now, you might be thinking, I didn't need to make that tree diagram to tell you there would be 12 possible outcomes. Maybe you noticed we have 6 possible outcomes when we roll that die. And over here, we have 2 possible outcomes when we flip that coin, either heads or else tails. If we had multiplied those together, 6 times 2, that would also equal 12, wouldn't it? And that's what is known as the counting principle. We're counting 6 heads, 6 tails. I mean, 1 heads, 1 tails, 2 heads, 2 tails. But you can make it faster by saying, well, you have your 6 options here, and each paired with one of 2 possible outcomes here. So we could just multiply 6 times 2 and know there would be 12 possible outcomes in this situation. I could have done that on the previous example too. There were 2 main dishes listed here, and there were 3 side dishes here. And if you take 2 times 3, you end up getting a total of 6 possible outcomes. And as you can see here, 1, 2, 3, 4, 5, 6. We had 6 different outcomes in our sample space. All right, if you roll both of these dice or number cubes, and I need to move my picture out of the way here. I'll put it right there. If you roll both of these dice or number cubes, how many possible outcomes are there? Well, again, you could do this the easy way. You have 6 possible outcomes here, and you have 6 possible outcomes here. So if you just take 6 times 6, what do you end up with? Well, you end up with 36 possible outcomes. I don't have a lot of space. I'll have to abbreviate possible outcomes. You get the idea. 36 possible outcomes here. 6 times 6, right? 6 times 6. If you roll both of these dice or number cubes, how many possible outcomes are there? There are 36 possible outcomes. I could show every one of the possible outcomes in a table. And so I've done that here. And so on my first roll, I could roll a 1, a 2, a 3, a 4, a 5, or a 6. Any of those could come up when I roll this die here. And on my second roll, I could roll a 1, a 2, 3, 4, 5, or 6. So there are 6 possible outcomes there. And if you look in my table and count these up, 6, 12, 18, 24, 30, 36 possible outcomes. Okay? So how many possible outcomes are there? 36 possible outcomes. All right, check this out now. I got a bonus question for you. How many of these possible outcomes will total 10 or greater? Let's say you're playing a board game and you want to get a total of 10 or greater to move your piece on the game board. And so let's see how many of them give us a total of 10 or greater. And 4 and a 6 would total 10, wouldn't it? I'll just start circling some of these. 5 and 6 is greater than 10. 6 and 6 is greater than 10. 5 and 5 is 10, so that's good. 5 and 4, no good. 6 and 4, that's 10. 6 and 5, that's 11, so that's 10 or greater. Everything else, 6 and 3 is 9, and everything else would be a smaller sum. I have 1, 2, 3, 4, 5, 6 of these possible outcomes will total 10 or greater. 6 of the 36. If you were to simplify that, that'd be 1 out of 6. That would give you a 10 or a greater. So if you're wondering, why can't I ever roll like a large sum when I'm rolling dice? Well, you really only have a 1 in 6 chance of rolling a 10 or greater. Okay, one last question here. You are buying, well, let's skip that one. Let's look at this one here. You are going to select one item from each category. How many different desserts can we make from this menu? Ooh, we have an ice cream menu. And we have some flavors, we have some different toppings, and we have 2 different types of cones, waffle or sugar cones. Ooh, waffle cones, they're good. Anyway, I have 1, 2, 3, 4, 5 flavors. I have 1, 2, 3 toppings, and I have 2 types of cones. So to find the number of different desserts we can make, just multiply those together. 5 times 3 times 2 is 30. So we have 30 different desserts that we could make from these options on this menu. I'll see you tomorrow.